Hello students, A2 chemistry, chapter is electrochemistry, lecture number 5. In this lecture, we are going to study another application of standard reduction potential. In this lecture, we will study what is oxidizing agent and what is a reducing agent, how to decide about an oxidizing and reducing agent, and how we can make comparison by using standard reduction potential to decide which one is the best oxidizing agent and which one is the best reducing agent. I will also tell you in this lecture how to construct an electrochemical cell for getting maximum voltage, having maximum spontaneity, and we will also write down a balanced chemical equation for an electrochemical cell by using this application. Okay, let's start. First of all, you must remember from your previous knowledge, you also know that very well, what is an oxidizing agent and what is a reducing agent. The complete definition that you can remember for oxidizing agent, it is any chemical substance that oxidizes others but itself is reduced. It is known as oxidizing agent. Simply speaking, you can also say, simply you can write down in your exams even also, you can write down oxidizing agent is the substance that itself undergoes reduction, and reducing agent is a substance that itself undergoes oxidation. Now what can happen, you can be given chemical equations for a number of different half cells in your exams, and a number of different questions that can be asked that we will discuss in this video. For example, you can see I am giving you chemical equations for a number of different half cells. For example, for copper half cell, for chlorine, bromine, iodine half cell, and the half cell of Fe2 plus and Fe3 plus. Now for these half cells, you will also be provided with standard reduction potential value. For example, standard reduction potential of copper half cell is plus 0.34 volt, chlorine plus 1.36, bromine plus 1.08, iodine plus 0.54 volt, and iron half cell plus 0.77 volt. So this information will be given to you in the exams, and based on this information you can be asked about the oxidizing and reducing agent. One particular question that can be asked, how you can guess which materials, which substances in these equations are oxidizing agent and which materials are reducing agent. Just remember, as I told you in the beginning, what is an oxidizing agent? That itself undergoes reduction. So which materials are undergoing reduction? In all these equations, in the forward direction, oxidation is taking place. So that is why you can see the materials which are written on the left hand side of these equations, they are oxidizing agent because they are undergoing reduction in the forward direction. So what name you can write on, what formula you can write on as an oxidizing agent? You can tell Cu2 plus, copper ion, chlorine, bromine, iodine, and Fe3 plus. These are the oxidizing agent, and simple reason you can remember, you can write down since they are undergoing reduction. And if it is asked for these half cell which materials are the reducing agent, you can say the materials which are written on the right hand side of these equations, they are the reducing agent. Why they are the reducing agent? Because in the backward direction they are undergoing the process of oxidation. For example, copper, Cu, chloride, bromide, iodide, and Fe2 plus. These are the material that would act as reducing agent. Okay, remember we are focusing these half cells, these five half cells, these five chemical equations to predict oxidizing and reducing agent. Next question, along with one reason that can be asked, which one of these is the best oxidizing agent? Now you will have to choose a best oxidizing agent and a best reducing agent. Now how to choose a best oxidizing agent? Just keep in your mind, oxidizing agent is the one that undergoes reduction, and best oxidizing agent is the one that can undergo reduction more easily. More easily mean its standard reduction potential must be more positive. It must produce maximum voltage. So if you look at these half cells, you can identify quite easily that which one of them is undergoing reduction most easily, producing maximum voltage, giving maximum output. You would have become able to identify it is chlorine. So why chlorine? Because you can see it has produced maximum voltage out of these 5 half cells, and it can produce 1.36 volt when it is undergoing reduction. So your answer for best oxidizing agent would be chlorine gas is the best oxidizing agent. And what reason you will write down? You will write down that since its standard reduction potential is most positive. Whenever for a given number of half cells, for a given number of chemical equations, you are asked to find best oxidizing agent. This is the reason that you must keep in your mind, and you should write down as an explanation that the half cell whose standard reduction potential is most positive, it is the best oxidizing agent. Likewise, now if you want to decide which one is the best reducing agent, now best reducing agent, I told you they must undergo oxidation. So materials which are written on the right hand side of the arrow, they are the reducing agent. And if we go in the backward direction, they will undergo oxidation in the backward direction. When they will undergo oxidation, then what will happen? The potential for these half cell will be known as standard oxidation potential. For example, for copper, the standard oxidation potential would become minus 0.34. For chloride, standard oxidation potential will become minus 1.36. For bromide, minus 1.08. For iodide, minus 0.54. And for iron 2, minus 0.77. So these are the standard oxidation potential that we have written on the left hand side of these equations. Now you can choose which one of these is the best reducing agent, the one that has most positive standard oxidation potential. But right now you can see not even a single substance is having a positive standard oxidation potential. So what you will do, instead of this, you can use the word that the most are the best reducing agent, strongest reducing agent is the one whose standard oxidation potential is least negative, the one who requires minimum amount of electrical energy to undergo oxidation. So right now what will be your answer? Your answer would be copper. Copper, you can see its standard oxidation potential is least negative. So whenever you are asked to give answer, you can write on answer since its standard oxidation potential is most positive or least negative. So this reason you can give for as an explanation for the best reducing agent. Moving on, next thing you must remember, now you have come to know what is the best reducing agent and what is the best oxidizing agent. Now if out of these 5, if you combine these two half cell containing best oxidizing and best reducing agent, you can construct an electrochemical cell that can produce maximum voltage out of these 5 half cells. Which electrochemical cell can produce maximum voltage, can have maximum spontaneity? The one that is a combination of copper half cell and chlorine half cell. When we will combine copper half cell with chlorine half cell, we can get maximum voltage out of these 5 half cells. Now so the next question that can be asked, to write down a balanced chemical equation showing maximum voltage, showing maximum spontaneity. Now what you will do, you have identified half cell with having best reducing agent, you have identified half cell having best oxidizing agent. You just look at both these and identify the half cell whose standard reduction potential is most positive. The half cell whose standard reduction potential is mathematically greater, that half cell always undergoes reduction, it becomes cathode. And the other half cell whose standard reduction potential is lesser mathematically, it must become anode and it must undergo oxidation. So right now you can see chlorine, its standard reduction potential is mathematically greater, so chlorine half cell will undergo reduction. So what you will do for writing equation for this electrochemical cell, in the chlorine half cell we will carry out the process of reduction. It will act as cathode, chlorine plus 2 electron plus 2 chloridine, chlorine plus 2 electron giving 2 chloridine. Now remember that when you are going to write down equation for that half cell which has become anode, you will have to reverse its equation that is provided to you in the data booklet or in the question paper. So what you will do with this copper half cell, since it is undergoing oxidation, so its product will become reactant and its reactant will become product. So what you will do with this equation, you will start with Cu, it will undergo oxidation, it will become Cu2 plus 2 electron. Now if you will take a sum of these two half equation, the first equation is reduction, the second is oxidation, you will get a sum of these two equations, that would be redox reaction. Electrons will be crossed out and the final equation that we will get, Cl2 plus Cu gives 2Cl1 negative plus Cu2 plus. Now this is a balanced chemical equation for an electrochemical cell that can give maximum voltage out of these 5 cells. And now you can also find the voltage produced by this half cell by using the formula standard cell potential. How we can find standard cell potential for an electrochemical cell? Standard cell potential, it is always equal to standard reduction potential of cathode minus standard reduction potential of anode. Now what is the standard reduction potential of cathode for this half cell, for this electrochemical cell? It is plus 1.36 minus plus 0.34. If you just use the calculator, you can get the standard cell potential for this electrochemical cell, it is plus 1.02 volts. Now this is the cell potential and this is the maximum voltage that an electrochemical cell can produce out of these 5 half cells. Moving on, let's do some practice. Keeping in your mind this information, you can answer these questions that are asked in your past papers, that have been asked in your past paper and that can be asked in your exams. Look at this typical question. Even this question you people are studying from your O levels. These two compounds, you will have to choose which one is the best oxidizing agent. We are using these two compounds even from your O levels and we also use them in AS organic chemistry. Now the first compound is potassium manganate 7 and the second compound is potassium dichromate 6. So you can easily identify which one of these two is best oxidizing agent. Which one of these two is best oxidizing agent? You know very well potassium manganate 7 KMnO4 is the best oxidizing agent. But right now in your A2 exams, when you are going to answer this question, you will have to quote the numerical value of standard reduction potential of both these compounds from the data booklet and then you will make a final conclusion. Now let's take the chemical equations of both these oxidizing agents from the data booklet. Remember, in KMnO4 the oxidizing nature is shown by MnO4 1 negative and in potassium dichromate oxidizing nature is shown by Cr2O7. So we will ignore potassium spectator ion in both these compounds. So for MnO4, which equation you can find in the data booklet? MnO4, whenever it undergoes reduction, mostly MnO4 1 minus, it becomes Mn2 plus. So you must pick this equation from the data booklet. If you look at the data booklet, the standard reduction potential for this half cell is plus 1.52 volts. And dichromate whenever it is reduced, mostly it is reduced to Cr3 plus. That is why we observe a color change from orange to green. So we get Cr3 plus 7H2O. And if you look at the data booklet, the standard reduction potential for this half cell is plus 1.33 volt. Now you can give a justification. You know very well KMnO4 is a best oxidizing agent, it is a strong oxidizing agent, and now after quoting these values you will give a final conclusion why KMnO4 is the best oxidizing agent, since its standard reduction potential is most positive, that is why it is best oxidizing agent. So your answer is correct now, that KMnO4 is the best oxidizing agent. Likewise, another question from your past paper, if you look at group 17 elements, chlorine, bromine, iodine, the question can be asked, what is the trend of oxidizing nature from chlorine to bromine to iodine? trend of oxidizing nature. Again, what you will have to do from the data booklet, you will pick the equations for these elements, half equations for chlorine, bromine and iodine, and you will also note down the standard reduction potential for these three half cells, and then you can make a comparison. Let's look at, these are the half equations for these half cells of chlorine, bromine, iodine, and the standard reduction potential of chlorine half cell is plus 1.36, bromine plus 1.08, iodine plus 0.54. Now you can guess quite easily which one of these three is the strongest oxidizing agent. It is chlorine. Why? Because its reduction potential is most positive. And which one is the weakest oxidizing agent? It is iodine, because its standard reduction potential is least positive. So what you can answer in this question, you can say from chlorine to bromine to iodine, oxidizing nature decreases. Why oxidizing nature decreases? Since standard reduction potential becomes less positive. Since from chlorine, bromine to iodine, standard reduction potential, its numerical value is decreasing. That is why oxidizing nature decreases. So this is how you are supposed to answer in your exams for oxidizing and for reducing agent. Let's take one more example, one more question from your past paper. Which one is, of these is the best reducing agent? Now this time you have been given chloride, bromide, iodide, ions. Now there are two different ways by which you can give answer. One, obviously by using these standard reduction potential value, which in this case, what you will do, these standard reduction potential value, they will become standard oxidation potential. Why? Because chloride, bromide, iodide, in the backward direction, they are undergoing oxidation. So the standard oxidation potential of chloride would become minus 1.36, bromide minus 1.08, iodide minus 0.54 volt. Now what you must remember, that which one of them is the best reducing agent? It is iodide. Why iodide is the best reducing agent? Since its standard oxidation potential is least negative. So this is the answer that you are supposed to write in, that why iodide is best reducing agent, since its standard reduction potential is least negative. So this is one reason that you can give while deciding best reducing agent, keeping in your mind standard oxidation potential. There is another reason for the deciding best reducing agent that we studied in AS group 17. What is that? The reducing nature, it also depends on radius or size of an ion. What is a reducing agent that can undergo oxidation? And what is the best reducing agent? The one that can undergo oxidation easily. Which ion can undergo oxidation easily? That is bigger, that is larger in size. And whenever an ion is smaller in size, it is difficult to remove an electron from that ion due to stronger pull of nucleus. In this case, chloride ion is the smallest, so it cannot lose electron easily. It is difficult to undergo oxidation, so it is the weakest reducing agent. Iodide ion is the best reducing agent, since it has largest radius. It can lose electron easily due to its largest radius. I hope you would have enjoyed this lecture. Thank you for your time. Bye bye.